Have you ever looked up at the night sky and felt a sense of wonder? Countless stars twinkle like distant diamonds, each with its own story. But hidden among these celestial wonders are mysteries that have baffled humankind for centuries. One such enigma is the connection between the smallest particles of dust and the most massive objects in the universe: black holes. How can something so small create something so powerful? The answer lies in the heart of stars, where the elements that make up everything we know are forged in the crucible of nuclear fusion. From the carbon in our cells to the iron in our blood, we are all made from the remnants of stars that lived and died billions of years ago. This cosmic dust, scattered across the universe by supernova explosions, becomes the building blocks for new stars, planets, and even life itself. But the journey doesn't end there. Under the relentless pull of gravity, this cosmic dust can also collapse in on itself, forming incredibly dense objects known as black holes. These cosmic behemoths warp the very fabric of space-time, creating regions where gravity is so strong that nothing, not even light, can escape. Join us as we unravel the mysteries of the cosmos, exploring the incredible journey from stardust to black holes. It's a tale of creation, destruction, and the interconnectedness of everything in the universe. Look at your hand. It seems solid, real. But did you know that the atoms that make up your hand, the iron in your blood, the calcium in your bones, were all created in the hearts of stars? It's true, we are all made of stardust. Billions of years ago, the universe was a very different place. It was filled with giant clouds of hydrogen and helium gas. Over time, gravity caused these clouds to collapse, forming the very first stars. Inside these stars, a process called nuclear fusion began. Fusion is like a cosmic pressure cooker. It takes light elements like hydrogen and fuses them together to create heavier elements like helium, carbon, and oxygen. This process releases enormous amounts of energy, which powers the stars and makes them shine. When massive stars reach the end of their lives, they explode in spectacular supernovas. These explosions scatter the star's newly created elements, including the building blocks of life, throughout the universe. These elements eventually become part of new stars, planets, and even us. Our solar system, a cosmic oasis we call home, also began its life as a swirling cloud of gas and dust. Imagine a vast dark nebula, a cosmic nursery filled with the remnants of ancient stars. This cloud, mostly hydrogen and helium left over from the Big Bang, also contained heavier elements like carbon, oxygen, and iron, forged in the hearts of long-dead stars. About 4.6 billion years ago, something disturbed this peaceful nebula, perhaps the shockwave from a nearby supernova. This disturbance caused the cloud to collapse in on itself, pulled together by the relentless force of gravity. As the cloud contracted, it began to spin faster and faster, like a figure skater pulling in their arms. The center of the cloud grew hotter and denser, eventually igniting into the star we know as the Sun. Meanwhile, the remaining gas and dust flattened into a swirling disk around the newborn star. This disk, called a protoplanetary disk, is where our solar system's planets, moons, and asteroids would eventually form. Over millions of years, tiny particles of dust in the disk collided and stuck together, growing larger and larger. This process, called accretion, eventually formed the planets we know today. The inner planets, Mercury, Venus, Earth, and Mars, formed closer to the Sun, where it was too hot for lighter elements like hydrogen and helium to condense. These planets are rocky and dense. Further out, where it was colder, gas giants like Jupiter and Saturn formed, gobbling up vast amounts of hydrogen and helium. Section 4. 8 Minutes of Magic: A Photon's Journey. The Sun, our nearest star, is a giant ball of hot gas, constantly undergoing nuclear fusion. Every second, it releases an unimaginable amount of energy in the form of light and heat. This energy travels through space as tiny packets of light called photons. Imagine you are a photon, born in the heart of the Sun. You are surrounded by trillions of other photons, all jostling for space. Suddenly, you are ejected from the Sun's surface, flung out into the vastness of space. You travel at the speed of light, the fastest speed possible in the universe. Even at this incredible speed, it takes you about 8 minutes to reach Earth. During your journey, you pass by Mercury, Venus, and countless asteroids, each a silent witness to your epic voyage. Finally, you reach Earth. Some of your fellow photons are absorbed by the atmosphere, warming our planet. Others are reflected back into space. But you are lucky. You strike the surface of a leaf, providing the energy a plant needs to make food through photosynthesis. Your journey, while seemingly insignificant, is essential for life on Earth. Without the sun's energy, our planet would be a cold, lifeless rock. Section 5. Cosmic Abyss. Unraveling the enigma of black holes. Imagine a place where gravity is so strong that nothing, not even light, can escape. This is a black hole, one of the most mysterious and fascinating objects in the universe. Black holes are formed when massive stars collapse at the end of their lives. Think of a star as a giant balancing act. The star's gravity constantly tries to pull everything inward, while the energy released by nuclear fusion pushes outward. For most of a star's life, these forces are in equilibrium, keeping the star stable. However, when a massive star runs out of fuel, the outward push of fusion stops. Gravity wins, and the star collapses in on itself. This collapse compresses the star's core to an incredibly small and dense point, called a singularity. The singularity is surrounded by an invisible boundary called the event horizon. Anything that crosses the event horizon is trapped inside the black hole forever, unable to escape its gravitational pull. Black holes are invisible to telescopes because they don't emit light. However, astronomers can detect them by observing their effects on nearby stars and gas. Section 6. Architects of galaxies, black holes, and cosmic evolution. Black holes, despite their destructive power, play a crucial role in the evolution of galaxies. They act as cosmic architects, shaping the distribution of stars and gas within galaxies. At the center of most, if not all, large galaxies lies a supermassive black hole, millions or even billions of times more massive than our Sun. These supermassive black holes are thought to have formed in the early universe shortly after the Big Bang. As gas clouds were drawn in by the black hole's gravity, they swirled around them, forming accretion disks. These disks, heated to millions of degrees by friction, emitted intense radiation, creating powerful jets that blasted out from the black hole's poles. These jets, along with the black hole's gravitational influence, help to regulate star formation and shape the overall structure of galaxies. In a way, black holes are like the gardeners of the universe, pruning and shaping galaxies over billions of years. Their influence, while often invisible, is essential for the diversity and beauty of the cosmos we observe today. Section 7. Keep looking up. The universe beckons. The universe is a vast and mysterious place filled with wonders that continue to amaze us. From the smallest particles of stardust to the most massive black holes, everything in the cosmos is interconnected, woven together by the fundamental laws of physics. As we have explored the journey from stardust to black holes, we have only scratched the surface of our understanding of the universe. Countless mysteries remain, waiting to be unraveled by future generations of scientists and explorers. So the next time you look up at the night sky, remember that you are looking at the remnants of ancient stars, the building blocks of life itself. Remember that the universe is a dynamic and ever-evolving place filled with beauty, wonder, and endless possibilities for discovery. Keep looking up, keep asking questions, and never lose your sense of awe and wonder. The universe beckons.